In this lesson, we're going to review factoring trinomial quadratic functions. To review, when we have a quadratic and it is in ordered form, we use A often to denote the leading coefficient. B will be the letter that we use to denote the linear coefficient, and C will be the letter that we use to denote the constant real number. For example, in the expression 4x squared plus 19x plus 12, A would be equal to 4, B is 19, and C is equal to 12. Today we're going to practice using the AC method for factoring. While there are many different approaches to factoring, this is one that works well for students. We will begin with our first example, and we will factor that expression we were just looking at, so 4x squared plus 19x plus 12. The first step is that we identify our coefficients a, b, and c, so 19 for b and 12 for c. And we will find the product a times c. So this is called the AC method. We're going to find a times c. 4 times 12 gives us 48, so our product AC is equal to 48. We want to find two factors of AC which have a sum of b. So our goal right now is to find two factors of 48 which have a sum of 19. Now when we start this process, 48 has many different factors. So on this first line, 48 is 24 times 2. However, that isn't the pair that I want because 24 plus 2 is equal to 26. And keep in mind, we want a sum of two factors which have a sum of 19. So 48, when I continue, 48 is 12 times 4, so I could look at that, but the problem is 12 plus 4 is equal to 16, so that's not quite what we want either. 48 is also 6 times 8, but again, that's not equal to 19. We get 14. 6 plus 8 is 14. But continuing this, we finally recognize, so 48 divided by 3 is 16. Alright, well 16 plus 3 is equal to 19, so this will be our magic combination. So we have found two factors of 48 which have a sum of 19. What we'll do on the next slide is we'll use those two factors and we will rewrite the middle term. So here I have 4x squared plus 19x plus 12. Since 48 was equal to the product of 16 times 3, and the sum of those two terms gives us b, the middle term, we're going to rewrite the middle term in terms of that sum. So I have here 19x, I'm going to split it up into the sum of 16x plus 3x. So we have exactly what we started with, but we ripped apart this 19 into the sum of two numbers. So these are completely equivalent statements, but this is kind of a trick that will help us. Now, you'll recall we've been practicing factoring by grouping in class already. So notice that now when I pull that middle term apart, I'll have four terms separated by an addition sign. So 4x squared, 16x, 3x, and 12. Since I have an even number of terms, I can factor by grouping. So for every two terms, we're going to factor out the greatest common factor. For 4x squared and 16x, both of those terms have a 4x. So you can see that we pull the 4x out front. And in parentheses, I call those our leftovers. So when we pull the 4x out, we're leaving an x in the first place holder, and then the 16x, we're going to pull the 4x and I leave a 4. You can see if you multiplied through, if you distributed the 4x back through the terms in the parentheses, you'd have exactly what we started with. So we're not changing anything, we're just factoring it. So for the first two, we've factored out of 4x, and these parentheses will be our leftover terms. For the last two here, for 3x plus 12, well, 12 is divisible by 3, so I've pulled out a 3 out front, and I am left with x plus 4. Well, this is looking nice for us because now we've factored this from 4 terms into 2 terms separated by an addition sign. So my first term here has an x plus 4 in parentheses, and my second term also has an x plus 4 in parentheses. That means that I could factor out the x plus 4. I'm left with a 4x from the first term then, so I've left that in parentheses, and a 3 from the second term, so I've left that in parentheses. And you will notice that we have completely factored this quadratic into the product of x plus 4 times 4x plus 3. Now, if you were to graph this quadratic, so if you were to consider this maybe y equals 4x squared plus 19x plus 12, then you can see that it has two zeros, and we can spot one pretty quickly. The first one here, negative 4 on the left, and I can see that that's indeed a 0 of one of our factors. And for the second one, it might be a little hard to see if it were labeled here, but since I've got this labeled, we can see this is negative 3/4. Negative 3/4 here. So negative 3/4 happens to be the 0 of the second factor. So this tells us, this graph helps us check our work that we have indeed factored this quadratic. In summary, when we're using the AC method, the first step is always to order your expressions and then identify your coefficients A, B, and C. You will then find the product A times C. You want to find two factors of that product which have a sum of B. Once you find those, you'll rewrite the original expression by replacing the middle coefficient with the sum of those two factors. This will allow you to factor by grouping. You will have an even number of terms. And factoring by grouping, you'll maybe have two steps to get that completed, and you should have your quadratic completely factored. We'll do one more example of this factoring. So for 6x squared minus 19x minus 7, this expression has some negatives. When we find AC, we see that we have 6 times negative 7, which gives us a product of negative 42. So we need two factors of negative 42, which have a sum of our middle term, negative 19. So keep in mind, when you're trying to come up with factors, if I need a sum of negative 19, one of those factors is going to have to be negative, and we probably want the bigger one to be the negative term. Fortunately, 42 is divisible by 2, it's even. So when I think about dividing 42 by 2, I have a product here, negative 21 times 2. Negative 21 plus 2 is actually equal to negative 19, so this will work really well for us. So we'll rewrite our expression using those two factors. So we found factors of AC which have a sum of negative 19. So we'll rewrite our expression. Negative 19x is the sum, negative 21x plus 2. Once I have rewritten the expression, I now have 4 terms. I'm able to factor by grouping. So for every 2 terms, I'll factor out the greatest common factor. 6x squared and 21x, they both have a 3x in common. So I've pulled the 3x out front. This leaves me with 2x from the first term and a negative 7 from the second. Now for the last 2 terms here, the last pair, 2x and negative 7 have nothing in common. And you can see, just for teacher reasons, I pulled out a 1 and left those in parentheses. Now the parentheses aren't necessary, they aren't required, but since I've done that, you can see that if you consider this to be the sum of 2 terms, both of those terms have a 2x minus 7 in them. So my next step will be to factor that 2x minus 7 out, the common relative, and then the leftovers from the first one, I'll leave a 3x and a 1 as a placeholder for the second. Remember, you could always check my work here by multiplying this out and distributing. So this is the factored form for 6x squared minus 19x minus 7. And again, we could also check our work by graphing. When I graph this quadratic, then you can see that it indeed again I have 2 zeros, and one of those zeros is 3.5, which is half of 7. So this will be the 0 for the first factor, and we can see the other one is a negative 0.333, which reminds us of negative 1/3. And you can see if you plug negative 1/3 into the second factor here. Negative 1/3 times 3 is negative 1 plus 1, and this will go to 0. So this would be another way to check our work using a graph. We're now going to practice some problems in class. Remember that you always want to factor out the greatest common factor first. If you're left with a quadratic trinomial, you can use the method that we just discussed today. So you're going to find two factors of the product AC which have a sum of b. You rewrite that middle term with the sum of those two factors, and then you will complete the problem by factor by grouping. So we'll now go ahead and complete the class set of problems in groups.